Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, 4 over 3. Cosecant, 5 over 4, that's hypotenuse over opposite. It also is sine, flipped upside down. Secant, yeah, 5 over 3, hypotenuse over adjacent. And again, secant is cosine upside down. And cotangent, yeah, is the reciprocal of tangents. It's the adjacent side over the opposite side. It is 3 over 4. Okay, so any questions there? These are just the basic definitions of all of these different trig ratios that we will see. There are only 6 of them. We can't add any more because there are only 6 fractions you can make out of these sides. Okay? Cool. All right. So let's try another problem. Okay, so here's a different question. So this time I'm just telling you, hey, there's this angle, here's its sine value. Find these other trig ratio values. What are these other fractions? So it might not seem like I'm giving you enough information, but of course I am. We just have to think about what information has been given to us. So we're talking about sine. We're talking about a trig ratio. Let's start by drawing a right triangle. This is always a good first step from now until the end of trigonometry. If you're not sure what to do, draw a right triangle. You'll probably get at least 1/4 of a credit for that. Not necessarily. Don't hold me to that. Okay. Now, to represent this angle, let's just pick one of these angles to be theta. We're just drawing a representation of our problem. I'm going to put theta right there. Okay, fine. So, 8 over 17, what information about this triangle is the sine ratio giving us? Yeah, it's giving us the opposite side. And it's giving us the hypotenuse. Or at least the ratio between them. So, where would the hypotenuse be here? The way I've drawn this, well, it's going to be over there. And then the opposite side, based on the angle that I picked to call theta, is going to be over there. Now that I have this information drawn onto a triangle, maybe this problem becomes somewhat easier. Now, if I'm going to find cosine, let me write this down. There's hypotenuse. Yeah, I need the adjacent side and the hypotenuse, right? Okay, I already know what the hypotenuse is. It's 17, but what's the adjacent side, or how do I find it? Okay, so I'm going to use the Pythagorean theorem. And so I'm going to say a squared, or just some variable squared, plus 8 squared equals 17 squared. And then I'm going to solve for a. So what's 8 squared? 8 squared is not 15. Yeah. 17 squared is 289. Subtract. A squared is 225. Take the square roots. A is exactly 15. That's the side right here. So the adjacent side is 15. So there's my cosine value. It's adjacent over hypotenuse. Once I drew this as a right triangle, it became a really simple problem. From just reading it, it seems complicated. It's not. This is a recurring theme in trigonometry. Draw a right triangle. It'll make your life a lot easier. What about the cotangent? That's what over what? Or which two sides? Yeah, cotangent is adjacent over opposite. Adjacent, 15. Opposite, 8. Okay, so that's cotangent. It's 15 over 8. Now, once you have all three sides, of course, I could ask you for any of the trig ratios. And if you have all the lengths of the sides, you can give those ratios. All right. So, to help keep all of this information straight in your head, an easy way to do that is to try and remember which ratios are reciprocals of which other ratios. So, in other words, sine, which we already said is opposite over hypotenuse, is the reciprocal of which of these other new ratios? Yeah, it's the reciprocal of cosecant. So in other words, we're going to say sine is 1 over cosecant. So when we say 1 over, we're just saying it's the reciprocal. Now, similarly, cosecant is the reciprocal of one of these other ratios. Which one is cosecant the reciprocal of? Cosecant's hypotenuse over opposite. Its reciprocal would be opposite over hypotenuse, which is the sine, right? So, if you flip something upside down and then flip it upside down again, you get what you started with. So in other words, if two things are reciprocals, they are both reciprocals of each other, kind of like with inverses. But they're not inverses. That's something. Similarly, cosine has a reciprocal. Which ratio is the reciprocal of cosine? Adjacent over hypotenuse, flip that. Hypotenuse over adjacent. Secant. And by the same logic, secant is the reciprocal of cosine. Now, there's one more pair left. Nope. One of them is tangent, and the other one is cotangent. And it turns out, yes, they are reciprocals of each other. Tangent is opposite over adjacent, cotangent, adjacent over opposite. Okay. So these are handy reciprocals. They're nice for a lot of reasons. One, it's just going to be easier to remember than trying to straight up memorize all of this. And there's another little handy thing to notice here. Notice that in these pairs of reciprocals, each one has a ratio that starts with a C. Sine and cosecant. One of them starts with a C. Cosine and secant. One of them starts with a C. Tangent and cotangent. One of them starts with a C. Okay, so a lot of people try to put sine and secant together, but since neither one of them starts with a C, they're not reciprocals of each other. Okay, so something to notice there. And we want to try and remember this with as little brain space as possible. Don't memorize, unless you really, really want to, all of these. And we'll use these enough that you'll pretty much know what's what very soon. But instead, try to remember this. Which one is the reciprocal of which other one? And And then, since you already know some square, you can just flip it upside down. Okay. So next, we're going to learn an important trig life skill for your trig life. This is called solving a right triangle. Now, when we say solving, I'm going to write this on the next page where there's more room. Okay, so when we say solving a right triangle, what we mean is, number one, finding the length of all of the sides. And number two, although not necessarily in that order, finding all of the measurements of the angles. So how long are the sides? How big are the angles? If we know all of that stuff, we have solved a right triangle. We know all of its secrets. Now, I'm not gonna move it. I'm just gonna say more stuff. So let's talk about how we can do this. So finding all of the side lengths. We've already done that once in a problem. Let's see, what did we do on... It's gone. What did we do on this? Alright. I need everybody to stop talking because it's making it really hard for me to say a simple sentence. Okay? So can we all just stop talking and try to pay attention? That would really help me out a lot. And by consequence, it would help you out a lot too. Okay. So what did we do on this example right here when we had a missing side length? How did we find it? Yeah, we used the Pythagorean theorem. So one way that we can find a missing side length is with the Pythagorean theorem. Now, to be able to use the Pythagorean theorem, what information do we have to already know? What do we have to already know? Yeah, we have to already know two of the side lengths. And then you can find the third one. That won't always be the case. But there's another way to find lengths of sides of right triangles. This is the one that usually comes up in, say, physics, when you use trigonometry. This is using the trig ratios. And so you can use a trig ratio to find a length of a side. Here you don't need to know two sides, you need to know one side and one angle. And if you know that, you can use a trig ratio to find a different side. Okay. We can also find angle measurements. Now there's the easy case in which you already know what two of the angles are. How would you find the third angle? Yeah, subtract from 180. Because all of the angles have to add up to 180, so if you already know two of them, you can figure out what's left over. So again, here you have to already know two angles. One of them, of course, is going to be the 90-degree. But let's say I only know the 90-degree angle. I don't know one of the other ones. And maybe I have some side angles. In that case, again, I can use trig. But to find an angle, I have to use the inverse trig ratios. So that's when I have one side and one angle to use. Or sorry. Wait, what am I? No. Erase that. That's not what I use. Who said that? So to use the inverse trig ratio to find an angle, because that angle is going to be your unknown in the equation, you're going to have to know two side lengths to be able to solve that equation for theta. So here we need to know two side lengths. Okay. And these are the strategies we're going to use to try and solve a right triangle, either to find its sides or its measurements. Let's try a quick example where we just solved for a single angle so that we can talk about how those inverse trig ratios worked. Again, you've probably used them before. It's when you do like second sine, -1. But let's talk about that to make sure we're all on the same page. So let's say I've got this angle. I want to know how big it is, but I don't. Instead, I know, I'll just use the same triangle from last time. Instead, I know these two sides. Okay, so to solve for this angle, I can't subtract from 180 because I don't know what this other angle is, but I can supposedly use some inverse trig. So to set this up, we need to pick a trig ratio. And we're going to base that on the known sides. So which two sides do we know? Well, if this is the angle that we're interested in, which side would the 8 be? Yeah, it's opposite from the angle. And which side would the 17 be? Is that adjacent? No, it is hypotenuse. I mean, yes, it is hypotenuse. It is not the adjacent side, even though it does happen to be adjacent to the angle. It is the hypotenuse. It's special. Okay, so which of my trig ratios ties the opposite and hypotenuse together? Sine does. Now there's another one that does. Cosecant also does. Would you rather use sine or cosecant? Probably sine. Is there a cosecant button on your calculator? No. Not on my calculator, at least. Unless you've got a fancy special calculator. So we're going to use sine because we have the opposite and hypotenuse sides. So let's start by setting up just the normal sine equation. Sine, and then what goes in the parentheses? The angle, which is theta. We don't have a value for the angle. What we do have are the values of the opposite side and the hypotenuse. 8 and 17. And for those of you who've done this recently, you probably remember automatically what to do. But let's make sure we know why. So, when you're solving an equation, here's a little side bubble. Let's say you have 3x equals 7. And you want to solve for x. What do? Why? I hear mumbling. Yeah, it gets x by itself, and it cancels out this other 3, right? Because multiplying by 3 and dividing by 3 are inverses. You use inverses to cancel stuff out, inverse operations. Or if you have x plus 3 equals 7, then you do what? You subtract 3. And you do it to both sides. On one side it cancels out, and on the other side it changes your value. So you have x equals 4. Alright, solved that one. Okay, so we're going to apply the same logic here. This isn't a new idea. It's the same thing you always do when you solve equations. If you're trying to get something by itself, then you cancel out whatever is over there with it by using its inverse. So we're going to apply the inverse sign to both sides. So this is not sine times theta. Sine is a function. And we represent inverse functions by using this -1 as an exponent. Confusingly, we also use -1 as an exponent to denote mathematically it's a reciprocal. But this is not a reciprocal, it's an inverse because sine is a function. So what we're going to do is apply the sine inverse to both sides. So sine inverse of whatever's on the left-hand side equals sine inverse of whatever's on the right-hand side. Okay, it's just like over here when we divided both sides by 3. We used its inverse. We're doing the same thing here. We're using the inverse of the thing we want to cancel out. And what you really have here, these two functions put together, that's called function composition. And what should you get when you compose a function with its inverse? What should be left over? Ooh, it was on the final. Now, usually we had an x here. And so, when you do the composition, you just have x left over. Yeah, well, here the variable is theta. So when you compose these, all that's left is going to be theta. So in other words, they cancel out. And then on the other side, you have this thing. And what do you do with this thing? Yeah, plug it into your calculator and try to get an answer. Okay. So I'm going to do sine. But I'm going to do second sine. That's the sine inverse. So there's my -1. And in parentheses, I'm going to put this fraction, 8/17. And then I'm going to press enter and let the calculator do the hard work. Okay. So how many of us got 0.4899573263? Raise a hand. Did. Who did? Cool, me too. So it must be right. Right? Because I got it, 4 other people got it. What did you get, Justin? You shook your head. How many of you got 28.97? Okay. So which one's right? Is it 0.489? Let's call it 0.49. Is it, what was it, 28 point? So what's the difference here? Somebody probably knows. We both typed in the same thing. If you don't believe me, here, I'll type in the same thing again. Sine inverse of 8/17. It's the same thing, right? This time I got 28.1. So what's the difference? How can I type in the same thing and get 2 different answers? You know, is my calculator broken? Are all of our calculators broken? Is it a conspiracy? Russians have hacked into our calculators to give us wrong answers. Oh, okay. So there are 2 different units we can use to measure angles, right? So you have to tell your calculator which units you want before it gives you an answer. So which of these seems more like a normal degrees answer that you would get? Yeah, the 28, and that's true. This is 28 degrees. And it gave me degrees because my calculator is in degree mode. But if I put my calculator in radian mode, which is the other way to measure, another way to measure angles, it's not cheating, it just depends on what answer I want. I made it give me the answer that I wanted, which in this case was both of them. So I can make it give me the radians answer. It's going to give you the one that you tell it to give you, or the one that the person in the last class told it to give them if you don't check the mode. So, look out for that. So which of these answers is right? It turns out both of them are. But usually, unless specified otherwise, we're going to want the degrees. And we will talk about radians. They turn out to be really useful. But if we're just looking at a triangle, solving a right triangle, we're probably going to want degrees. Okay, so the correct answer would be 28.1 degrees. If you get an answer that's a really small decimal like this, 0.49 degrees would be a tiny angle. You might want to double check that. Make sure you're in the right units. Okay, and is this degrees Fahrenheit or degrees Celsius? Okay, you're right, it's meters. Okay, so let's combine all of our skills and try to solve a right triangle. Okay, so I've got a couple of different triangles here. I'll help you out a little bit with the first one, and then I'll make you do the second one without me. So first, let's look at triangle A. I'll call this one DEF. Alright, so this first triangle, we've got to solve the triangle. In other words, we want to find all of the sides. We want to find all of the angles. But first, let's pick the low-hanging fruit, as they say. What would be the easiest thing to find first? Yes, the third angle right here, angle A. So what would I do? Yep. So 90 plus 20 is 110. So we're going to subtract from 180. Nope. All right. So 90 plus 120, whatever that is, and then subtract that from 180. And that's going to give you the answer for angle A, which happens to be what? So A is 70 degrees. And I can come back in and write that here, 70 degrees. Okay. So we got the easy one out of the way. We're 1/3 of the way done. There are 6 different pieces of this triangle. 3 angles, 3 sides. We need to find these other 2. Usually, we call the side across from capital A, we call it little a. And the side across from capital B, we call little b. So let's try and find little a and little b. Now, I know some angles, I know one side, so which strategy would help me here? Can I do the Pythagorean theorem? No. So What was my other option? Horatio? Oh, a trig ratio. Okay, I don't know Horatio. That's not really a nice guy. Alright. So, to use a trig ratio, the first thing you have to do is pick an angle to base your ratio off of. It doesn't matter which one you pick, but you might as well pick the one that you know is right because it was given to you. So, the 20-degree angle. Okay, so what if we use this 20-degree angle? Let's find A first, little a. So we're going to find little a. And again, we can't use the Pythagorean theorem. We need a trig ratio. So if we're using the angle 20, is A the opposite, adjacent, or hypotenuse side? Okay, so A is adjacent. And which side do we know? Which side length? We know the hypotenuse. So we want the adjacent. We know the hypotenuse. So we should use cosine, because cosine is the ratio between the adjacent and the hypotenuse. So, okay. So we're going to set up our equation. Cosine of, and which angle were we basing that off of? 20. It's a degrees. It's not radians. So I'm going to put a degree mark there. Equals the adjacent side, which is A, over the hypotenuse, which is 18. And let's see if we can solve. So how would I solve for A? Yeah, multiply both sides by 18. So I would get 18 times cosine of 20. And whatever that is, that's going to be A. And then what do I do? Before I plug it in the calculator, what would be a good thing to check? Yes. It turns out mine's not. So it would give me the wrong answer. Now, real quickly, I'm going to do it with the wrong mode in there. And we'll see what my answer looks like. $7.3. Okay, that seems pretty reasonable, right? Nothing wrong with 7.3. But if I did that, then this side B over here, and if I went through and solved this problem, this side B, would it be longer than 7 or shorter than 7? It should be shorter, right? Just based off of these angles in the triangle. But if it was shorter than 7, if it was like 6 and 7 and 18 wouldn't actually make a triangle, right? It would be a T-Rex triangle. So this answer can't be right. So look at your answer. Make sure it actually makes sense. This one does not. So if I put it in degree mode and type in the same thing, I get a more reasonable answer, 16.9. So that's what I'll put down. And in general, if I don't tell you, 1 decimal place is probably fine. Not degrees. 16.9, whatevers. Like so. And then, how would I find the third side, side B? You guys are Pythagorean theorem masters. So go. Pythagorean theorem. PT, in other words. Don't forget to take the square root at the end. Otherwise, you'll have a side length of 38. And that can't be right. That's longer than the hypotenuse. Did anybody else get 6.2? Okay, so something to look for here. If you get an answer that's longer than 18, you know you did something wrong. Because the hypotenuse is supposed to be the longer side. So most of the time, if you make a mistake, you'll end up either with a triangle that can't really be a triangle, or you'll end up with some side longer than the hypotenuse. So So just look at your triangle after you've solved it and make sure your triangle looks okay. Could that really be a triangle? Yes, it could. If you really, really want to make sure your answer is right, of course, you could check the Pythagorean theorem. Does a squared plus b squared equal c squared? Probably. So does 6.2 squared plus 16.9 squared equal 18 squared? That's 324.05. 18 squared is 324. So basically, yeah, with a little bit of rounding involved. Okay. Of course, we use the Pythagorean theorem here. So you could still have a mistake back here somewhere as well. So make sure your triangle looks okay. Biggest side across from the biggest angle. Smallest side across from the smallest angle. Medium side across from the medium angle. Just like the good old days in geometry. All right. Your turn. Here you're starting off with different equations, so you're going to have to work this in sort of a different order. All right. So, real quickly, to find this third side, of course, you could use the Pythagorean theorem. To find one of the angles, so let's say I want to find this angle. Now, I can call this angle angle F. So there are a lot of different ways and different orders in which you could do these things. Let's say I wanted to find angle F based off of just the information that I have now. Now, if you know all three sides, then really you can use any of the ratios. But if I only know these two sides, which trig ratio would involve this angle F? Yeah, opposite and adjacent, so that's tangent, right? So to find F, I would use the tangent. So I can call this angle theta if I want to. It's already called F, so I'm just going to call it F. And so if I'm looking for angle F, which side would be opposite, which side would be adjacent? Yeah, the opposite would be 12, and adjacent would be 10. And because I'm solving for the angle here, I have to cancel out the tangent. And to cancel stuff out, I use inverses. So I'm going to do the tangent inverse of whatever I already have on each side. So the tangent inverse of the tangent of F is just F. And then the tangent inverse of 12/10 is something that my calculator will tell me. And if I'm in degree mode, it will even give me the answer in degrees. I am in degree mode. So I'm going to type that in, that second tangent, and in parentheses I put the fraction, 12/10. and I press enter, and I find out that angle F is about 50 degrees. So this angle is about 50 degrees. And what if I wanted to find the other angle? Could I set up another trig ratio? Sure, but I don't have to. What could I do? Yeah, add up the angles. So 90 and 50 is 140. What's 180 minus 140? 40. Okay, so that's how you solve a triangle. Now, there is homework here. So it comes from a textbook, but you don't have to carry the textbook. I'm just going to scan the page. And you don't have to do every single problem on the page. You'll need to do number 7, number 9, number 13, number... Uh-oh. Well, I wrote them down somewhere else. So look on Google Classroom. That's where I'll have the pages scanned, and I'll put the numbers up there too. Expect it to take you about 15 to 20 minutes. Not a whole lot of stuff. If you have an idea of what you're doing, if you don't have an idea, then you'll know that you don't have an idea, and you need to work harder on it. And we're going to have a quiz on this Friday. That's the next class. All right, so come to class ready, ask questions if you have them, and I think it's time to go to your class.